What's my favorite food? No results. Okay. How much did I spend at Aldi? Hi, my name is Raghu, and I'll be walking you through my project called as PhotoMind. Just before this, what you saw is a limitation that exists within all our photo applications, be it in Apple, be it in Google. It can find photos that look like receipts, but it can't read the numbers on them. It has no idea what $4.99 means. That's the gap. Apple Photos does visual similarity, Google Photos can read text and images, but neither can answer the questions you would actually ask about your own life. How much did I spend this week? Where did I shop the most? There's real information locked in these photos, and nothing on my phone lets me get at it. That bugged me enough to build something that does. So here's what I built: PhotoMind. PhotoMind analyzes a photo library with GPT-4o Vision, builds a JSON knowledge base out of it, and you ask questions in plain English, you get answers with conference scores and source photos. The stack is CrewAI, React, Fast API, plus a reinforcement learning layer on top. But honestly, easier to just show you than explain it. Let me just show you. Now, I have loaded the knowledge base with the photos of bills and food items and some other screenshots which I find very useful. So this is how our library looks like. Oh, there is one. Well, under a second, grade A confidence you got, and 5 Aldi recipes have been listed here, each with a relevant score and evidence from the OCR text. Same question my phone couldn't answer at all. That felt pretty good the first time it worked. Now, click on any photo, you get the full image, the file name, the relevant score, the evidence snippet that matched. Now, show me my electric bill. Just to give you more information that like I don't have an electric bill here listed because all the demo corpus have been PI. There has been no PI information in it, and it has a grade F. No matching photos found. I don't have an electricity bill in my library, and the system says so instead of guessing. This is something I care about a lot. I would much rather get I don't know than a confident wrong answer, especially when it's about money. Now, let me search something even more. At an instant, you get grade A. It counted across all 53 photos and ranked stores by frequency. That's not just finding one photo, it's a pattern analysis across the whole library. Now, there's a deep reasoning mode too. Sends the query through the full Crew AI pipeline. 3 GPT-4o calls, gives you a long narrative answer, takes like around like 15 to 45 seconds and costs a few cents. So I'll skip it live. Um, you can browse all indexed photos with their metadata, check evaluation metrics, or look at the system architecture diagram here. Now, let me go through the architecture first. Here. So, how does it actually work under the hood? Let me walk you through the architecture. There are two pipelines here. Ingestion is sequential, scans photos, runs each one through GPT-4o Vision, writes a structured record to the knowledge base. Each photo gets entities, OCR text, a description, image type, and a confidence score. The queries go through a hierarchical crew here. The next one. A controller agent figures out what you're asking, hands it to a knowledge retriever that does the actual search, then an insight synthesizer writes the final answer. Now, this is the core file. About like you know this has like around like 999 lines, like four search categories have been done. One, the factual search. Factual does entity matching and OCR text search. That's your how much at Aldi queries. Semantic does keyword overlap on description. Show me pizza photos. Behavioral counts patterns across the whole library. Which store do I shop at most? And there's an embedding strategy as well with the mini LM that gets fused with factual results using reciprocal rank fusion. The confidence grading is A through F. If nothing matches, the system declines instead of making something up. The whole point of the reinforcement learning extension is keeping that intact. Now, so at this point, the search worked, but I had a problem. The system was sometimes confidently returning the wrong photo. And if this is supposed to be a personal finance tool, and that's not just a bad UX, it's actually misleading. That's where the reinforcement learning comes in. Two RL approaches I have used here. Both were required by the assignment, but I picked problems where they genuinely help. First one is contextual bandit for query routing. I have used Thompson sampling, UCB1, epsilon greedy, each choosing between the four search strategies. Context is a 396 396 dimensional feature vector, 12 handcrafted features plus a 384 dimensional mini LM embedding clustered into four groups with k-means. Second is DQN confidence calibrator. I adapted this from the lunar lander DQN we built earlier in the course. Same core algorithm but a very different problem. Five actions have been used: accept high, accept moderate, hedge, requery, and a decline. The interesting one is requery. It's non-terminal. The agent can say the search strategy didn't work, try another one and reevaluate. That's what the discount factor actually do something. You get real temporal credit assignment through the Bellman equation, not just single step classification here. The reward matrix is the part that I'm opinionated about. It's asymmetric on purpose. Correct decline is plus 1.0, but a silent failure, a confidence but wrong answer is like minus 1.0. Think about it, like if this is a personal finance tool and you confidently tell someone the wrong dollar amount, that's worse than saying I'm not sure. I wanted the system to learn that the same instinct, and it does. One thing I'm proud of here is all the RL training runs offline here. I've just run the RL training here. I built a photo mind simulator that pre-computes all four search strategies on every query once, caches everything, then runs thousands of training episodes against the cache. So you can iterate on the RL without burning money on OpenAI. This trains like bandits and DQ1 agents across 5 seats and 4,000 episodes each. Bandit converges to about like 66 percentage, DQ1 to about like 0.815 average reward. So yeah, there are 98 queries which we did across 3 sets, compares 5 configurations, 5 seats each, 95% confidence intervals, and the number that matters, the recommended config, rule-based routing plus DQN gets like around like 86% retrieval accuracy and a 2.8% silent failure rate. The baseline is 4.7. The DQN cut confident, but wrong answers by 40%. Confirms that the DQN is what drives the silent failure reduction. The bandit helps on ambiguous queries where keyword rules break down, but rule based routing is already pretty strong on its own. Now, two figures worth looking at is the DQ1 rewards and the ablation comparison, which I just showed. The DQ1 reward convergence across 5 seats, it's about like 0.76 within like 500 episodes. And the ablation comparison, this is the full ablation. Recommended config is on the Pareto front. There are like 10 figures total in the repo. Regret curves, posterior distributions, action distributions, they're all in the report. Testing 90 unit tests across 3 files covering like reward computations, all for search categories, and both storage backends, all are passing. So That's PhotoMind. It started with me being annoyed at my phone and turned into a contextual bandit and a multi-step DQ and plugged into a CrewAI multi-agent system with a React front end and fast API backend. To wrap up, I just ran the query, what's the capital of France? Basically, the photo app should not answer this question. And it returned me with an F grade and no magic photos found. If I had to pick one design decision that defines this project, it's the reward matrix. Confidently returning wrong data is worse than admitting uncertainty. I built the system around that belief and the DQ1 learned that to respect it. All the training data stays local on my machine, and I have written 90 unit tests and generated 10 figures on the performance, and I also have a full technical report all available in the repo. Please do check it out. Thank you.